Okay, let's start with that puzzle. The neuron that wears many ats.
Yeah, let's drill down into that original misconception monosemanticity because it's just so intuitive. It's what we want to be true.
Of course. In that tidy, expected world, interpretation is. It's just a direct, simple lookup
A
table.
lookup table. Perfect analogy. If you're a network trying to detect faces, you expect neuron 100 to be the left eyebrow detector.
Right. It activates only when that one specific feature is present. It's a dedicated, reliable specialist. The moment it lights up, you know exactly what the network just saw. No ambiguity.
And that idea was so compelling because for a while it seemed plausible. I mean, it's how humans tend to build systems. We like modularity, so we projected that onto AI.
But once researchers had the tools to actually inspect the activation patterns of these large, powerful networks,
They consistently found the tangle. Polysemanticity is the rule, not the exception.
and this is where the mystery really kicks in, because the polysemantic neuron isn't just a little messy, it's bizarrely mixed. It fires for multiple features that, on the surface, have zero connection to each other.
Zero. And the initial reaction by researchers was, I think, genuine shock. We're not talking about a neuron that fires for, like, dog ear and wolf ear.
Because that would make sense. They're related concepts.
Exactly. We are talking about situations that just defy human logic. I mean, think about the examples found in the research. A single neuron might fire for a cat image, and a car image.
Okay, a cat and a car. I'm trying to find a link. Curves, headlights and eyes. I mean, you can stretch it, but it feels like a stretch.
It is.
Mhm.
And it gets more abstract. In a language model, a single neuron might code for the concept of an apple and the concept of a mountain.
An apple and a mountain. Okay, that one really sticks out. Let me try. I have to try and find a connection. If it's a visual feature, maybe it relates to texture. No, mountains are rocky, apples are smooth.
What?
Okay, what about scale? No, apples are small, mountains are huge.
Yeah.
Is it possible they both relate to being natural objects in contrast to, say, a keyboard?
And that is a perfectly logical, perfectly human attempt to find a shared semantic link.
But it's wrong.
But that's the polysemantic puzzle. The research strongly suggests those features, apple and mountain, are not fundamentally linked by a common semantic concept or even a shared visual structure. The network is using them for tasks that are just statistically independent.
So it's not a conceptual link. It's a convenience thing.
It's computational convenience. The network doesn't think apple and mountain are both things that exist outside. It thinks, I need to represent feature A, apple, and feature B, mountain, and they'd appear rarely enough in my training data that I can safely cram them into the same physical space without causing a total disaster.
So they're jammed together because of an architectural necessity, not a conceptual one.
Precisely. And we see this ambiguity everywhere. Another one that's often cited is a neuron that fires for smiley faces and mathematical symbols.
It's even weirder.
It is. And when we, the external observer, see that neuron activate, we have no idea if the AI is processing an equation or a piece of internet shorthand.
The moment researchers realized this was widespread, the whole foundation of interpretation just cracked. The neuron, which we assumed was the fundamental readable unit,
It's now fundamentally ambiguous. It is the definition of a black box, but at the micro level.
so